Hello everybody, I'm Alexy Khrabrov, the organizer of SF Scala, and here are our location at Nitro, where we have a great meetup tonight with Bill Venners talking about Scala Test 3.0 and Data Fellows talking about Agile Data Science with Scala. And we have both Data Fellows here with us. I'll let them introduce themselves and tell us what Data Fellows are all about.
Yeah, so I'm Andy Petrella. I've co-founded Data Fellows with Xavier. Initially, I was the creator of the Spark notebook, which is one of the most important notebook around when you want to deal with Spark, but especially with Scala. And I will let Xavier present himself.
Yeah, so I'm Xavier Tordoir, co-founder of Data Fellows with Andy. So I'm a physicist. I've done a lot of work in bioinformatics as well, and so we are very fond of distributed technologies and data science. And we want to solve problems in this field of data science.
Cool. So Andy, you mentioned Spark Notebook, and that's the tool we've been using at Nitro and actually doing joint work on explaining some pieces of machine learning, including neural networks, using Spark Notebook with great results. So can you tell the audience a little bit about what is Spark Notebook? Why is it good for data science?
Yeah, why is it good for data science is pretty easy, I would say, because I am a data scientist, so I have a mathematical background. And 3 years ago, I started with Spark after 1 year of Scala. And very soon, I had to have this kind of tool to do my homework, right? And so actually, I had created a company at that time already, and I had to create a product. So I had to, do a lot of machine learning using Spark, and I was completely fed up about either creating SBT project or REPL, using the REPL. So I decided very quickly to create a Spark notebook. I started with something homemade, and then I switched to another one, which is the current one, and is based on initially on the Scala notebook that I made evolve towards what is now. So why it is good is because it includes a lot of things that data scientist needs, like reactive plotting in order to, to explore quickly and efficiently the data sets that they have. It's not about having dashboards. It's more about, getting the sense about the data rather than, trying to expose final results using it. So it has a lot of features coming from different tools that we've used as data scientists, like the list of variables that have been defined in notebook, and also easy configuration, so you don't have to bother with connection with the clusters and things like this. So it has a lot of features that are both in the Scala data science, plotting, machine learning stuff, and also connecting with clusters, which is more kind of data engineer / DevOps things.
Mm-hmm. And you mentioned, it's called Spark Notebook. And so it's basically systematically optimized for usage with Spark. Right? So when you mention Spark cluster, that's because we can run Spark on a big cluster, and usually it involves all the work for kind of DevOps person, and data scientists probably do not have enough time to kind of do that, right? So if you help them with that, that's kind of it's a big deal, right? So
exactly. And each user can tune the way Spark will be used, because each notebook is actually behind the scene a real JVM it has its own Spark context. That means that the data scientist can tune how the process is behaving on the cluster by tuning how many cores is dedicated for the job, and also the memory dedicated for the job, and so on and so forth. So you can tune it the way you like it.
So, for those folks who are not really familiar with Spark and Scala ecosystem, right, and probably most data scientists tried Jupyter Notebook and IPython, can you outline kind of the advantages of using Spark? What kind of problems are more suitable for Spark and kind of Spark Notebook than just plain old IPython?
Right. Actually, so the Spark Notebook UI is mainly the Jupyter one. However, behind the scene, everything has been implemented to use only JVM stack, so you don't need to have any Python or whatever installed on the machine. And so the real difference between both of them is that the UI has been extended a lot in order to provide extra features, like this panel of variables, but also a chat window, and then plotting libraries are very sticky to the Spark notebook, so that when you return a data frame, for instance, automatically it will be rendered as a table. But also if you return a list of doubles, for instance, it's gonna plot a line chart automatically if you like. So there is something like this that are very adapted to the way you will work with the Spark notebook, because we only work with Scala. We can do a lot of things which is not available in the others. So yeah.
And Spark obviously is a distributed system which basically can go through data much faster.
Exactly. So there are a few features that are very interesting when we deal with the Spark and the Spark notebook, because there is something really painful that you use Spark, is that you have to go regularly to Yarn or Mesos to check the logs, for instance, in order to see if you had some problems or whatever. In the Spark notebook, for instance, we have implemented, thanks to ICA and WebSockets and reactive programming, we have implemented a way to capture all the logs in the Spark cluster and gather them into the browser console. So you don't have to go to the cluster manager, you just have to go to your browser console and check all the logs in there. So you will have all the possible exceptions you may have, and the classical ones are, of course, serializable errors and null pointer errors will happen.
That's great. I mean, I was playing with Spark 101 notebook, right? And it gives you all the links to all the pieces of Spark UI itself, right?
Yeah.
So I think it's actually browser-based environment is a really good way to learn a lot about Spark itself and see it in operation, see what data is cached, right, and what tasks are executing. So I think this is really convenient. So let's kind of zoom out a little bit, so you're talking about agile data science with Scala and Spark, and kind of you are setting up this company to do that, right? And so since last time we met, kind of there was a lot of work, and Xavier joined, right? And so I want to ask you guys, what kind of data science challenges you solve for your customers? What kind of areas? Right, and basically, how do you see kind of Spark Notebook giving them an advantage? How it's kind of a great tool for them to use to solve these challenges?
Okay, I want to give a few words before passing the mic to my buddy Xavier. So the thing is that we had discovered a lot of problems while using notebooks in general, not only the Spark notebook, but in general, right? And the main purpose of the company that we have created is not to productize the Spark notebook per se, but is to allow people using notebooks to work efficiently towards the production environment, right? So because when you have a notebook, you're happy because you have done your work, but it's not finished because you have to integrate with other parties of your company, and more importantly, you have to provide information to the business, because those guys are the one that you have to satisfy, of course. And when I say business, it's not only customers, but also internal businesses, right? So this is what we want to face. And now I will leave Xavier explaining what we do in these different sectors.
Yeah. So what we observed often in the project we've been working on these years is that the business comes with a question. It can be, we work with insurance companies, for example, and there are many questions coming for marketing, which insurance product we should recommend to our customers and at what time. So these kind of questions are now addressable with the premise of big data, let's say. And so they come and they talk to the data scientist, and he knows how to solve the problem from a mathematical perspective. And so he's working on that, and he provides a solution. And it will come maybe with a report to the business, say, do that, and it will work. But things in practice should go further than that, because the business guy will ask the question several times. So you have to productize this work. And in order to do that, you have to enable something downstream of the work of the data scientist. Usually he works with tools. He may work with Python, he may work with R. How do you make it a product so that the business pushes on a button and he gets the answer he asks for before, but with new data, because data is streaming along the way. So you have to be really reactive and agile with the data flowing in. And you cannot ask the data scientists to make the end product for the business. So you need data engineers, you need DevOps to develop downstream. And this is where the problem arises, because it's a lot of work to get the data scientists work efficiently with what happens downstream, because those guys, they are very efficient, they know their work, but they need a way to communicate, because it's hard for a data engineer to understand exactly what the data scientist did. And so we're working on these kind of issues, and the Spark notebook is an enabler in some way, because we provide the data scientist with a tool that allows him to do his work. But because we're working with Scala, with types and so on, we're able to extract very valuable information on what it is with types. If he writes data into a table in a database, or if the output is a machine learning model, we can extract the information on this and provide this as schemas, Avro for instance, to the web engineer, and we can even generate the basic services as projects that are able to query this data, to make the service to make a prediction with the machine learning model. So the work is prepared, and we have Docker images that are being prepared as well and can be deployed on environment like a Mesos. So even the DevOps work is prepared with this solution, and so we have the communication between the different team players is made with the code that is generated. So they know what they're talking about because they have the code that is telling them. So it's easier for them to communicate and understand the needs of each other. So that's really what we are doing at Data
There's a
Feras.
common shared place that science data engineers can look at in the kind of graphical environment, understand the data, right, and see what's going on.
Yeah, exactly.
So I remember Andy mentioning that you guys work with genomics, right? And I wonder if you can explain and kind of to general data scientists, what makes Scala Spark a good tool chain for genomics, and how Spark Notebook can help in kind of genomic workflows.
Yeah. So besides insurance, we're targeting genomics. We have a background, so we have some knowledge into this field, and we know that there's a huge pile of, we could say, legacy code, because a lot of work has been done to analyze this data coming from these biotechnologies that are really growing at an amazing pace, and IT it's a hard work for IT to follow. So distributed technologies will be there to help process this data. When you think of genomics, actually the data is very simple. It's having the state of the DNA at different position along the chromosomes. So it's very simple data.
It's
actually.
binary decimal, just zeros and ones, right?
Yeah.
It's almost zeros and ones.
Yeah, it's ATCGs, but it's just like 0 and 1s. That's true. And most of the works consist of making kind of descriptive statistics. So it's just counting what happens at a certain position on a chromosome for a certain population. For example, people that are susceptible to a certain disease. What is their feature in the genomic sense? So it's descriptive statistics, and Spark is really good at counting. So it's the right tool to do this kind of work. And because we're talking about a lot of data, so a genome is 3 billion bases. When we look at a data set like the 1,000 genomes, which is the complete genomes for 1,000 individuals, we're talking about 30 million variable position on these chromosomes. So it's quite a lot of data, and so Spark is really there to help. And we've been doing some work on this data set using the Spark notebook on clusters, and you can really interactively make those countings, make those classifications of genomes in seconds or minutes.
So yeah, it sounds like it's perfect for Spark because it just has essentially unlimited memory if you can hook up enough machines, and then you can just distribute the collection. Right, so I guess if data scientists did not try this before, that's really stellar example of how you can just load the whole data set, right? And since it's in memory, it's fast, and you can build this faster. So I want to ask you guys about the plans. First of all, so data fellows, I really like the design. You have these cute animals. Can you tell a little bit what they signify? And I feel like you're looking for a new animal. Maybe you can describe.
Yeah. Regarding animals, so maybe it's due to the fact that we are Belgian and maybe we are screwed by the basis. No, actually, so initially, so we wanted to do a lot of machine learning, a lot of genomics, and a lot of medicals, and so on and so forth. And when we looked at the spectrum right now of toolkits, not only in genomics but in general for data scientists, we thought, okay, actually, people, enterprises, companies, toolkits are thinking that the data scientist is a monkey, for instance, right?
Okay.
Is a monkey because you just have to push buttons and automatically everything will be generated from him. You know, the models will be tuned, everything will go just fine, right? So they don't open all the doors for the people to work with the real data behind and creating new models. Okay, so we decided to...
monkeys, but for data monkeys.
Yeah, actually, this is monkey because but the data scientist knows that he's not a monkey, right? He knows that he can do better than that, right? But he's sticking with the toolkit that they have been provided.
Mm-hmm.
Right, so we said, okay, maybe there's a way to open those doors and then we can make them cool monkeys, you know? So, and of course, there is the monkey, which is the logo of the Spark notebook, because this one opens all the doors. Yeah, and then there is somebody which is very fancy, you know, is very smart and very, how to say, it has a certain notoriety. He's a llama, you know.
Okay.
Llama has these kind of things. So it's most probably representing Xavier. Monkey is me because I have the cap. And there is a rat. The rat is the poor animal in there that is constantly, the target for new medicines and things like this. So the guy is not part of the team because he would suffer quite a lot, actually. There is a bit of history behind that due to the refraction and the way we were understanding the current landscape.
This is great. This is a great analogy. Now I know better. It's good to be a data monkey with Spark notebook, right?
Yeah.
That enables a multi-monkey. That's great.
So I had something to add regarding genomics, for instance. There is something interesting when you play with Adam, which is the library that we use mainly when we deal with genomics, is that those guys have understood that types is very important and organizing the data is very important, right? So again, we don't have to think that the data is somewhere so we can process it right away. Thinking about how the data is structured and how the data is distributed is very important when we deal with distributed computing systems. So those guys has taken the specification of genomics data and they revamped it into another schema and stored them into Parquet, which then allows Adam to be very efficient when it comes to computation because he can do it in parallel efficiently. And not only on the Adam side they were smart enough to create types on that, but also on the other side of the spectrum, there is a alliance named Genomics Global Alliance for Genomics and Health. And those guys are like the W3C of genomics, and they are defining types also onto the different data sets that we use in genomics and health, and also a series of services that we have to implement in order to be compliant with them, so that different entities in the sector can communicate in a efficient manner, in a comprehensible manner, right? So this is a smart way of thinking about data pipeline these days, and it looks like that actually genomics sector has overstepped. They jumped like 2 or 3 generations of technologies, and they go further than the other sector. So this is very exciting about that. This is why initially we wanted to go in that direction, and we still go there. But also, genetics and health is also very related to healthcare in general and insurance. So we got a lot of traction. This is why we have a lot of customers in this area.
No, I noticed that it's kind of interesting because on the one hand, right, there is Adam, but on the other hand, most of bioscientists are still in Perl and Python. I was surprised. Half of them are using Perl when I did a talk at Penn last year. So, I think it's like on the one hand, technology percolates slowly. So I think it will actually be great help and great service to spread the word, right? And kind of try this thing. So I will this leads me to kind of my last question or kind of brainstorm, right? So we are planning to do preparing a hackathon, global hackathon for Scala and data. Right, because it kind of emerges that all the people using Scala, they actually pump a lot of data through it, and they use it for data pipelines from APIs. They use it with Spark, right? They use it in different contexts, but kind of it turns out that for whatever reason, Scala is good for data. So and we'll actually have this hackathon both on the tooling side, of the data pipeline side, but also we'll see if we can put together some interesting puzzles in genomics, working with Amplify and you guys. Right, so I just want you to kind of to think aloud, like why Scala is good for data, right? Like a lot of people are starting using data science with Python. They're taught Python, right? They're not being taught Scala yet. When they hear about Spark, not many people actually know at this point that Spark is already in Scala. So it's kind of good to kind of spread the word and explain why Scala is especially good for data. So I just want you guys to kind of think about this, right? Like mention why and what would make interesting problems people can try to play with data using Scala.
Yeah.
And maybe using Spark Notebook, of course.
Yeah, actually, in my track on working with data, I've seen many systems. I've started probably with some C, then went to C++, then I went into genomics. So Perl was the way to go, and again C if you want to be fast sometimes. Right. And then some R, a lot of R, and then some Java, which I never use for data analytics because it simply doesn't work. And then when I went into Scala, it was really kind of a perfect language for me to manipulate data, going into functional style. So really thinking about processing in another way, and especially when you're going into Spark, you're thinking about your data transformation, and it goes into the distributed world in a pretty much transparent way. Mm-hmm. So, but that is more specific to functional programming and using it as an interface, a paradigm for distributed computing. Mm-hmm. Now the specifics of Scala for me is that writing code, writing a function that will do some statistics on data, so a bit of transformation, selecting some features, counting them in a single function. It requires applying several transformations that are chained, working on a notebook that is interactive with Scala, that means types. It means that I just implement one step, execute it, and I see the type that is coming back. If it's good, then I write the next element in the chain. So writing a complex function may take just 20 minutes, and it's right when it's written, while with other languages or other environments, it's much more difficult because you write the whole shebang, then you write some tests, and you have to test everything. Yeah, maybe. Yeah, so that's for the specifics of Scala, of course, is that you manage problem in a much clever way. You defer the problems to the end, and it doesn't enter into your function definition. So it's really great for me. It's the way I work now and the way we work with data.
Yeah, I think this is a great summary, right? Like types help you not to know, and you work piecemeally. And you put together when you put together things which obey each other's types, they usually work, right? Like they work right away. I mean, maybe you need to kind of tweak the data a bit, data processing, but at least they will compile, they will run, and that's a huge advantage.
There are two things as well. So regarding functions, it's very interesting to think about it. I want to reiterate on that because when we deal with local machines, what we do is that we bring data in memory to the function and then we apply it, right? Mm-hmm. So this is how a local machine will work. But now we have to think differently, so that we have to send functions to the data in order to be applied, right? Mm-hmm. So this is why functional programming is very interesting, because they are first-class citizens, so you can think about the functions and then the system will send them over the data. Mm-hmm. But the data are remote, and that means that being helped by the type system is very interesting, because you do that on your local system, and then when you send them, you're sure that it's going to come to cope with the overall structures that you have defined so far. Now, when we deal with when we have Scala code, the interesting thing is that the tool chain that you will create towards the data itself to the production environment can remain the same language, I mean, because you deal the data, you consume it, you will take it from the outside world, you will put it in something like Kafka using a highly available and highly scalable collector in Scala, which is easy to deploy and maintain. Then you put it into Kafka, which is, by the way, Scala implementation. Then this Kafka can be consumed using Spark streaming, and then it's going to be pushed in Cassandra, which is Java-based, JVM again. And then you go through the machine learning that you can write in Scala thanks to Spark and the new libraries that are coming out of the wild right now in Scala. And then you can create the microservices in Scala again, highly available, highly scalable, very reactive. You push it into production, and then you can declare some new customers that you can consume it. And then if you are smart enough, then you declare web services per se, they can consume it the way they like it. Might that be in Python, or might that be in Node.js or whatever, they can do the way they like it, because this is not our responsibility to make them highly available or highly scalable, you know? Right. So using one single language and one single platform, you can do the whole thing from one end to the other end. And this is why I pretty much like Scala in general. But why not Java? Because Scala for me is a bit easier to think of and to deploy new stuff.
Because by the time you finish writing Java code, the problem went away already, right? Like you don't need the solution anymore because it's too late, right?
Yeah.
but actually, this is funny. It makes me think, right? Because you're talking about the hardest problems in data. You talk about machine learning, right, genomics, and then you talk about microservices. I thought maybe it's a misname. Maybe we need to call them macroservices, right? Because they're gonna solve big problems.
Yeah.
Right? So
with micro problems.
Yeah, they're composable, but they can actually encapsulate the whole Spark behind the service, right? Which can be sitting there full of genetic data, right? And that's so it doesn't mean they're small. It's just they're composable, right?
Yeah, they have to be highly available and using a resilient system is very important. So
once we have kind of an easy way to have these microservices spin up and combine, probably you can compose them in Scala the same way you compose functions, and maybe you can use Spark Notebook to visualize them.
Yeah, and then something interesting to note is that if you deploy services that are disconnecting from the cluster, the computing cluster, that means that you can very scale at very different levels, because if you have a new bunch of users that are coming into the platform, you don't have to scale your Spark computing framework cluster, which is very expensive. You just have to scale the services which are targeting another system behind that can scale already. So, I mean, this is also a matter of cost, scaling the services which are generally the small machines versus scaling the computing framework. I mean, there is this is no brainer. I mean, you should always scale the microservices instead of the computing clusters. So this is the difference for me between tools that are generating dashboard within the same environment without passing by the intermediate step, which is the service generation.
Oh, this sounds great. And actually, I think it's kind of very nice to fit the philosophy of Scala, where you have composable abstractions and composable functions, right? And we can do the same. Great. Well, thank you very much. That was a really good update, right, on Data Fellows. So we're looking forward to great things to come out of this, and we're looking forward to a talk.
Yeah, thank you. Thank you for receiving us.